This video we'll just cover some more terminology for polynomial functions. First thing I want to discuss is the linear factorization theorem. And it says if f of x is of degree n, where n is greater than 0, then I can rewrite f of x as a coefficient times x minus c sub 1 times x minus c sub 2, on and on and on, times x minus c sub n, where c sub 1, c sub 2, all the way through c sub n are complex numbers. Remember that 3 is also a complex number because I can write 3 as 3 plus 0i. 1/2 is also a complex number because I can write it as 1/2 plus 0i. So my rational numbers, my integers, my irrational numbers, they are all complex numbers. So what it says is that I can rewrite any polynomial function of degree n times a whole bunch of factors times some leading coefficient. Okay. The total number of zeros of the polynomial function is guaranteed to be degree n. Notice that some of them may not be real because that definition uses complex. So the number of real zeros has a maximum of n. Now, if I want to know the number of complex zeros, it would actually be equal to n. But the number of real zeros has a maximum of n. The next thing I want to discuss is what is called turning points of a graph. And a turning point of a graph is anywhere it goes from increasing to decreasing or from decreasing to increasing. And the maximum number of turning points of any polynomial function is n minus 1. For example, on a quadratic, which is x squared, n is equal to 2. So I have a maximum of 2 real zeros. And I have a maximum of 2 minus 1, or 1, turning point. And for quadratics, we actually have exactly 1 turning point. If you have a cubic function, n is equal to 3, so you have a maximum of 3 real zeros. And you have a maximum of 2 turning points. We're going to be using this information to come up with equations from graphs, or to be able to sketch graphs of polynomial functions.